Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. The AWS Certified Cloud Practitioner exam, currently referred to as CLF-C02, validates foundational, high-level understanding of AWS cloud, services, and terminology. In this video, we will be exploring 10 sample questions for this exam. The goal of this exercise is to review each question before exploring and eliminating incorrect answers, resulting in the correct answer being revealed. This is an essential technique for mastering AWS exam questions. Let's get started. A company needs to track the activity in its AWS accounts and needs to know when an API call is made against its AWS resources. Which AWS tool or service can be used to meet these requirements? Let us identify and interpret key phrases in the question that will help with answering it. The question opens with the need to track the activity in its AWS accounts, which suggests a focus on observability and auditing. The second part, when an API call is made against its AWS resources, is even more precise. Here, the objective is not just general monitoring, but capturing API-level events that provide insight into who did what, when, and from where. This sets a clear expectation. The tool must offer detailed logging of AWS service interactions and specifically log API calls, whether through the console, SDK, CLI, or automation tools. Option A, Amazon CloudWatch. CloudWatch is a powerful observability tool, especially for metrics, logs, and alarms. It helps track performance and operational health, and it can be configured to collect log data from various services and applications. However, it does not natively log all API activity across AWS services. While it can ingest logs, the actual event logging for API calls comes from a different service. Incorrect, because Amazon CloudWatch is essential for monitoring performance, not for auditing API usage across services. Option B, Amazon Inspector. Amazon Inspector is a security assessment service. It evaluates the security state of EC2 instances and containers by checking for vulnerabilities and deviations from best practices. It does not track operational events or log API calls. Its scope is automated security scanning, not activity logging or auditing. Incorrect, because Amazon Inspector identifies vulnerabilities, not user or API level activity. Option D, AWS Identity and Access Management, defines who can do what within your AWS account. It handles users, roles, permissions, and policies. While IAM policies govern access, they do not monitor usage. IAM has no built-in capability to log or track API calls. It only determines whether those calls are allowed. Incorrect, because IAM controls access, but it doesn't log activity or detect when actions occur. Option C, AWS CloudTrail. AWS CloudTrail is designed precisely for this use case. It records AWS API calls for an account, capturing details like the identity of the caller, the time of the call, the source IP address, and the request parameters. It supports tracking through the Management Console, CLI, SDKs, and AWS services, and delivers log files to Amazon S3 or CloudWatch logs for long-term storage or analysis. Whether you're investigating suspicious activity or setting up compliance auditing, CloudTrail is the authoritative tool. Correct, because AWS CloudTrail is purpose-built for logging API activity, making it the best fit for tracking AWS account operations. A company has a compute workload that is steady, predictable, and uninterruptible. Which Amazon EC2 instance purchasing options meet these requirements most cost-effectively? Choose 2. Let us identify and interpret key phrases in the question that will help with answering it. The phrasing of the question offers several clear signals that point toward specific purchasing strategies for Amazon EC2. When a workload is described as steady, it implies that the compute resources are needed continuously or for extended durations. The word predictable suggests that usage patterns are known ahead of time, meaning capacity planning can be done confidently without surprises. The term uninterruptible is critical. It immediately eliminates any option that comes with the possibility of forced termination, such as spot instances. Lastly, the phrase most cost-effectively adds a layer of financial strategy. It's not enough for the solution to simply work. It must do so in a way that minimizes long-term costs. Option A, on-demand instances. On-demand instances offer maximum flexibility. You pay for compute capacity by the second or hour with no long-term commitment. While they're great for spiky or short-lived workloads, they are not the most cost-effective for long-term, predictable use cases. Incorrect, because on-demand is reliable but costly for steady, predictable workloads. Option C. Spot instances. Spot instances let you use unused EC2 capacity at discounts of up to 90%. However, AWS can terminate them with just 2 minutes notice, making them unsuitable for uninterruptible workloads. Even if they are cost-effective, the lack of guaranteed uptime disqualifies them here. Incorrect, because spot instances are cheap, but can be interrupted. A poor fit for this scenario. Option E. Dedicated hosts. Dedicated hosts provide physical servers exclusively for your use. They're great for compliance-heavy workloads, such as those requiring license-bound hardware affinity, like Oracle or BYL scenarios. However, they tend to be more expensive, and their benefit lies more in compliant software licensing. Incorrect in this context because dedicated hosts offer isolation, not general-purpose cost efficiency. Option B. Reserved instances. Reserved instances are perfect for predictable, steady workloads. They allow you to reserve capacity in a specific availability zone and offer significant discounts, up to 75% over on-demand pricing. They come in 1-year or 3-year terms and can be paid fully, partially, or monthly. This makes them ideal when you know your long-term compute requirements. Correct, because reserved instances deliver deep discounts for predictable, long-running workloads. Option D. Savings plans. Savings plans offer similar discounts to RIAs, but are more flexible. Instead of tying to a specific instance type or region, compute savings plans apply across multiple instance families and even across Fargate and Lambda. You commit to a consistent usage level, and in return, AWS gives you substantial savings. They are ideal when the workload is steady and consistent over time. Correct, because savings plans provide long-term savings with more flexibility than RIs, perfect for predictable usage. Which AWS cloud service can send alerts to customers if custom spending thresholds are exceeded? Let us identify and interpret key phrases in the question that will help with answering it. The question is centered on budget alerts in the context of AWS cloud costs. The phrasing, "send alerts," is a strong indicator that the service must support proactive notifications. Then there's custom spending thresholds. This implies a user-defined monetary limit that, when crossed, should trigger some form of automated alert. So we're looking for a cost management tool in AWS that not only tracks spend, but can also take action when limits are breached. Option B. AWS Cost Explorer. AWS Cost Explorer is an excellent tool for visualizing and analyzing your AWS spend over time. It lets you filter by service, time period, or linked accounts. But while it is powerful for reporting and forecasting, it does not support alerting. It's purely observational. There's no built-in mechanism to send notifications when spending crosses a threshold. Incorrect, because it is great for visibility and trends, but lacks alerting capabilities. Option C. AWS Cost Allocation Tags. This service helps you categorize AWS resources so you can track and allocate costs. While it's a key part of setting up a chargeback or showback model within large organizations, it doesn't monitor spending or send alerts. It's just a metadata layer to better classify spend, not to track it dynamically or trigger alarms. Incorrect, because it is useful for organizing cost data, but not for active budget monitoring or alerting. Option D. AWS Organizations. AWS Organizations helps with account management, consolidating billing, managing service control policies, and setting service quotas. However, while it plays a role in centralized billing and governance, it doesn't provide mechanisms to set budget thresholds or send alerts on spending. It sets policies, not alarms. Incorrect, because it is good for central governance, but doesn't handle custom cost alerting. Option A. AWS Budgets. AWS Budgets is the purpose-built service for this exact use case. It allows you to define custom cost and usage budgets across linked accounts, services, or tags. Crucially, it can trigger alerts via email or Amazon SNS when your actual or forecasted usage exceeds the defined threshold. Whether you're tracking cost, usage, or RISP utilization, AWS Budgets offers fine-grained control and proactive alerting. It even integrates well with AWS Chatbot or ticketing systems for real-time ops notifications. Correct, because AWS Budgets is the only service in this list that supports customized thresholds with real-time alerting, making it the correct and complete solution for monitoring and managing AWS spending. A systems administrator created a new IAM user for a developer and assigned the user an access key instead of a username and password. What is the access key used for? Let us identify and interpret key phrases in the question that will help with answering it. This question zeroes in on a fundamental aspect of AWS identity and access management, the use of an access key. The situation describes that a developer IAM user was created and was assigned an access key instead of a username and password. In IAM, username and password combinations are typically used for AWS Management Console access, which is web-based. On the other hand, access keys are specifically used for programmatic access, that is, for making API calls via the CLI, SDKs, or other automation tools. So we are clearly dealing with a use case that involves programmatic non-console access. Option A, to access the AWS account as the account root user. This is incorrect because the root user is unique and tied directly to the AWS account itself, not to an IAM user. Access keys can be generated for the root user, but the question explicitly says the key was assigned to a new IAM user, not the root. Also, using the root account for daily operations is an anti-pattern in AWS best practices. Incorrect because root user access is not related to IAM user credentials. Option B, to access the AWS account through the AWS Management Console. This is a common misconception. Console access requires a username and password, optionally combined with MFA, but not an access key. An access key cannot be used to log into the console. It only works with programmatic interfaces like the CLI or SDKs. Incorrect, because access keys are not used for browser-based console login. Option D, to access all of the company's AWS accounts. This is misleading. IAM credentials are scoped to a single AWS account unless explicitly set up for cross-account access using resource-based policies or roles. The access key is not inherently multi-account. The access key for a user in account A does not give them access to accounts B or C unless those connections have been explicitly configured. Incorrect because access keys are account scoped unless explicitly configured for cross-account access. Option C, to access the AWS account through a CLI. This is the precise and correct use case. The AWS CLI command line interface relies on access keys for authentication and authorization. When a developer uses the AWS CLI to interact with services, those requests are authenticated using the access key ID and the secret access key. These credentials are set via environment variables, AWS config files, or through credential profiles, and are entirely designed for programmatic access. Correct, because IAM access keys enable secure programmatic access to AWS via tools like the CLI or SDKs. Which AWS service or resource can be used to identify services that have been used by a user within a specified date range? Let us identify and interpret key phrases in the question that will help with answering it. This question hinges on tracking service usage by a specific user over a defined date range. The phrases identify services used by a user and within a specified date range point us toward activity tracking, access logging, or audit-focused services. We're not looking for who can access something, which is about permissions, but rather who has accessed what and when. That temporal aspect, the specified date range, tells us that event history or API call logging is critical to the answer. Option A, Amazon S3 Access Control Lists, ACLs. S3 ACLs are used to manage permissions for S3 objects and buckets. They define who is allowed to access S3 resources. For example, granting read or write permissions to specific AWS accounts or users. However, ACLs do not log activity or usage history, nor can they show usage within a date range. Incorrect because ACLs manage access permissions, not usage history or activity tracking. Option B, AWS Certificate Manager, ACM. ACM is used to provision, manage, and deploy SSL/TLS certificates for securing network communications. While important for security, ACM does not track usage of services or user activity. It's focused on the lifecycle of certificates and their deployment status. Incorrect because ACM secures resources but offers no visibility into user activity or access logs. Option C, Network Access Analyzer. Network Access Analyzer is used for network connectivity analysis, helping validate and audit network paths across VPCs and other network configurations. It's great for ensuring that your intended connectivity policies are in place or for identifying unintended network access paths, but it doesn't provide user activity tracking or any event history within a date range. Incorrect, because Network Access Analyzer focuses on network reachability, not user-level service usage or access tracking. Option D, AWS Identity and Access Management, Access Analyzer. Access Analyzer in IAM is typically used to analyze resource-based policies and determine who can access your resources from outside your account. However, it does not give a historical log of which services were used by a user over time, unless the query is for CloudTrail logs. Correct in this context, as it is the best service to match the actual functionality described in the question, is from AWS CloudTrail logs, which records all API calls made within an account, showing which services were accessed, by whom, and when. That's the real solution to who used what and when. Which options are AWS Cloud Adoption Framework, AWS CAF, Security Perspective Capabilities? Choose 2. Let us identify and interpret key phrases in the question that will help with answering it. The question revolves around identifying capabilities associated with the security perspective in the AWS Cloud Adoption Framework. CAF provides structured guidance across various perspectives, like business, people, governance, security, and operations to help organizations plan and implement their cloud adoption. The security perspective is all about protecting data, systems, and assets, and aligning with compliance and risk management objectives. It focuses on risk assessment, identity management, infrastructure security, detection, incident response, and business continuity. Option A, observability. Observability refers to the ability to measure and understand the internal state of a system by examining outputs like logs, metrics, and traces. While observability plays a role in overall system health, it's not a core capability specifically outlined under the security perspective in AWS CAF. Incorrect, because observability is essential for operations, but is not a defined security perspective capability in AWS CAF. Option B, incident and problem management. This may sound security-focused, but incident and problem management in AWS CAF aligns more closely with the operations perspective. It deals with monitoring, response, and remediation of operational issues rather than just security-specific incidents. Security may overlap here, but AWS CAF differentiates general incident handling from security-centric incident response, which is separately defined. Incorrect, because this belongs under operations, not security, within the AWS CAF structure. Option E, availability and continuity. Although business continuity and availability are critical topics in secure cloud operations, in the AWS CAF, availability and continuity are primarily highlighted in the operations perspective. The security perspective deals with enabling secure environments and incident recovery, while true availability concerns fall under operational resilience and platform robustness. Incorrect, because business continuity is relevant but not categorized under the security perspective in AWS CAF. Option C, incident response. Incident response is a core capability in the AWS CAF security perspective. It focuses on detecting, investigating, and responding to security incidents promptly. AWS encourages building incident response mechanisms that are automated, repeatable, and testable, aligning with this exact perspective. Correct, because it is a fundamental part of the security perspective, ensuring quick reaction to breaches and vulnerabilities. Option D, infrastructure protection. Infrastructure protection is another direct and critical capability under the security perspective. It includes implementing safeguards such as firewalls, network segmentation, DDoS mitigation, and endpoint protection. These practices ensure the infrastructure is defended against external and internal threats. Correct, because it directly maps to the security perspective's goal of maintaining a protected infrastructure baseline. A user has limited knowledge of AWS services, but wants to quickly deploy a scalable Node.js application in the AWS cloud. Which service should be used to deploy the application? Let us identify and interpret key phrases in the question that will help with answering it. This question subtly points us toward a specific type of AWS service. First, the mention of a user with limited knowledge of AWS services clearly signals the need for a solution that prioritizes abstraction and automation, something that can shield the user from the intricacies of infrastructure setup, configuration, and scaling. Then, the requirement to quickly deploy adds another layer of urgency and simplicity, emphasizing that the ideal solution must offer a rapid, low-effort deployment path with minimal manual intervention. Finally, the phrase scalable Node.js application introduces a technical requirement. Not only must the platform support Node.js as a runtime, but it must also be capable of automatically handling increases in demand without the user needing to manually reconfigure resources. Option A, AWS CloudFormation. While powerful, AWS CloudFormation is primarily an infrastructure as code service. It's intended for users who want precise, programmatic control over resource creation using YAML or JSON templates. For someone with limited AWS knowledge, writing and managing CloudFormation templates adds unnecessary complexity. Incorrect because it is too advanced and infrastructure-centric for a beginner with deployment goals. Option C, Amazon EC2. Amazon EC2 gives users direct access to virtual servers, allowing full customization. However, this approach requires managing the OS, installing runtimes like Node.js, configuring scaling policies, and setting up load balancing. That's far too manual for someone seeking quick deployment with limited experience. Incorrect because it offers flexibility but lacks the automation and abstraction needed for ease of deployment. Option D, AWS OpsWorks. AWS OpsWorks is a configuration management service based on Chef and Puppet. It's powerful for managing complex application stacks but has a steep learning curve and is not ideal for users who aren't familiar with configuration as code paradigms or infrastructure automation tools. Incorrect because it is not beginner-friendly and too complex for rapid deployment of a simple application. Option B, AWS Elastic Beanstalk. AWS Elastic Beanstalk is purpose-built for this scenario. It allows users to deploy applications quickly without deep AWS knowledge. It automatically handles provisioning, load balancing, scaling, and monitoring. All the user has to do is upload their Node.js code, and Beanstalk takes care of the rest. It also supports rolling deployments and basic health monitoring, which makes it suitable for real-world workloads without overwhelming the user. Correct because Elastic Beanstalk provides the perfect balance of simplicity, scalability, and support for Node.js, making it the ideal choice for new users looking for fast deployment. A company wants to migrate its on-premises workloads to the AWS cloud. The company wants to separate workloads for chargeback to different departments. Which AWS services or features will meet these requirements? Choose 2. Let us identify and interpret key phrases in the question that will help with answering it. The scenario involves a company moving from an on-premises environment to the AWS cloud. First, the company wants to migrate on-premises workloads to AWS. This implies they're looking for services that support cloud-native organization, scalability, and manageability. However, the next part is even more revealing. They want to separate workloads for chargeback. This suggests that visibility into cost allocation per department is a primary concern. We're looking for tools that allow us to logically isolate resources and track usage at a granular level across a multi-account environment or through intelligent billing mechanisms. Option A, placement groups. Placement groups are used to influence the placement of EC2 instances on the underlying hardware. Their primary use is to optimize for network performance or fault tolerance, not for financial separation or cost tracking. Incorrect because it is not suitable for workload separation for chargeback. Option C, edge locations. Edge locations are part of AWS's global infrastructure used for services like Amazon CloudFront to cache data closer to users. While beneficial for reducing latency, they have no role in cost separation or departmental chargeback. Incorrect because it is irrelevant to billing separation requirements. Option D, AWS Config. AWS Config is a service that tracks resource configuration changes and compliance over time. While helpful for governance and auditing, it doesn't support workload separation or cost tracking tied to organizational units or departments. Incorrect because it is not related to financial chargeback or workload partitioning. Option B, consolidated billing. Consolidated billing is a core feature of AWS organizations. It allows an organization to combine billing across multiple AWS accounts to receive volume discounts. Critically, it still enables tracking usage and cost per individual account, which is perfect for chargeback models. Each department can be mapped to a separate account, and costs can be clearly identified. Correct, because it is highly aligned with the requirement for chargeback and cost clarity. Option E. Multiple AWS accounts. Using multiple AWS accounts is one of the best practices recommended by AWS for enterprise customers. Each department can have its own account, logically isolating workloads and making it easy to attribute costs, apply service control policies, and even enforce different security postures. When combined with consolidated billing, this forms a powerful model for departmental chargeback, correct? Because it is the perfect solution for separating workloads and aligning billing with departments. Which AWS service or tool can be used to capture information about inbound and outbound traffic in an Amazon VPC? Let us identify and interpret key phrases in the question that will help with answering it. The focus here is on monitoring inbound and outbound traffic within an Amazon VPC. This clearly places the requirement in the domain of network-level observability. The service or tool must be capable of capturing IP traffic metadata, enabling the company to analyze what kind of traffic is flowing through their VPC. Such a service would help with network diagnostics, compliance, and security monitoring. The question uses the word capture, which implies a passive logging mechanism rather than something that intercepts or alters traffic. Option B. Amazon Inspector. Amazon Inspector is an automated vulnerability management service. It assesses the security state of EC2 instances and container workloads by checking for software vulnerabilities or unintended network exposure. However, it does not capture network traffic or logs and is more focused on compliance and vulnerability assessments. Incorrect, because it is not suitable for capturing VPC traffic flow data. Option C. VPC Endpoint Services. VPC endpoint services allow AWS services or custom services to be accessed privately from within a VPC. While they improve connectivity and security, they do not have any built-in capabilities for capturing traffic logs or monitoring flows. Incorrect, because it is not relevant to traffic logging. Option D. NAT Gateway. An gateway enables instances in a private subnet to access the internet while preventing inbound access from the internet. It facilitates routing of outbound traffic but does not log traffic itself. You would need VPC flow logs to observe what's happening through it. Incorrect, because it handles traffic routing, not traffic logging. Option A. VPC flow log. VPC flow logs are designed specifically to capture information about the IP traffic going to and from network interfaces in your VPC. They provide details such as source destination IP, ports, protocol, and bytes transferred. This data is useful for security analysis, performance monitoring, and network troubleshooting. It directly satisfies the need to observe inbound and outbound traffic patterns. Correct, because VPC flow logs are the purpose-built solution to capture IP traffic information inside a VPC. A company wants a fully managed Windows file server for its Windows-based applications. Which AWS service will meet this requirement? Let us identify and interpret key phrases in the question that will help with answering it. The company is looking for a fully managed solution, which means it doesn't want to handle infrastructure setup, maintenance, patching, or backups on its own. The requirement is specifically for a Windows file server, which further narrows down the scope to a service that supports SMB, Server Message Block Protocol, Active Directory integration, and Windows-based file storage. Since this is to be used with Windows-based applications, compatibility with the Windows ecosystem is non-negotiable. Option B. Amazon Elastic Kubernetes Service, Amazon EKS. Amazon EKS is a managed Kubernetes service used to deploy, manage, and scale containerized applications using Kubernetes. It's not designed to serve as a file server and does not provide native file sharing or SMB support. While you can mount storage volumes in containers, that involves a different paradigm entirely. Incorrect, because it doesn't satisfy the requirement of being a fully managed Windows file server. Option C. Amazon Elastic Container Service, Amazon ECS. Amazon ECS is similar to EKS, but is AWS's native container orchestration solution. Like EKS, it is used to run containerized workloads. It does not serve as a file server and certainly not as a managed Windows-compatible file system. Incorrect, because this option is unrelated to the core requirement of persistent shared storage for Windows applications. Option D. Amazon EMR. Amazon EMR, Elastic MapReduce, is used for big data processing frameworks such as Apache Spark, Hadoop, and Presto. It's optimized for analytics workloads, not for hosting file servers or providing file system services for Windows applications. Incorrect, because there is no direct relationship between EMR and Windows-based file sharing. Option A. Amazon FSx. Amazon FSx is a family of services that provides fully managed file storage built on popular file systems. In particular, Amazon FSx for Windows File Server offers a fully managed native Microsoft Windows file system, accessible over the SMB protocol. It integrates with Microsoft Active Directory, supports DFS namespaces, user quotas, and other enterprise Windows features. It is purpose-built for use cases like this: Windows-based applications needing a shared, persistent file system without administrative overhead. Correct, because Amazon FSx, specifically Amazon FSx for Windows File Server, is the only service designed to provide a fully managed Windows file system for Windows-based applications. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.